ERPs were supposed to solve the challenges in operations faced by companies. But most companies do not use their ERP to manage production planning and scheduling. They use it more for recording inventory transactions or financial reporting. What is it that went wrong?
The problem is rooted in the implementation of ERP in Indian companies. The business remains a black box known in parts to a few people within the company, and only a few know the whole system or the interactions with it. In most cases, these people do not know what the ERP can and cannot do. So what happens is bringing the requirements and capability to the same platform becomes a big challenge. Thus, the configuration of ERP is limited by the knowledge of the users and the implementers.
But all systems are dynamic and are modified continuously, aren't they?
Over time, under different leaderships, different kinds of reports are developed. Very few changes are made at the configuration level. So mostly what happens is these are Excel based or Z reports as the managers are working in their silos. They are not doing anything at the configuration level. So these are made with a very narrow approach and there are many repetitive developments. So after considerable time is spent, there might be many reports in the system, but only 30% of these reports are used for day-to-day operations or for any annual or biannual meetings and stuff like that. The other 70% becomes obscure and gradually even the users forget about it. See, one of the expected impact of having an ERP is to bind various departments together to work towards one common objective. This objective is never met because the solutions itself were generated from working in silos. Within the ERP, along with layers of Z reports and Excel-based reports, the divide between the departments actually widens.
How can companies transform their operations for a better performance without changing or re-implementing their ERPs? Is there a way out?
We at Vector Consulting Group study the problems of a system first, not of individual departments, but of the system. Then we devise the to-be process. The solutions come first. The software is customized according to the customer's world. We do not force fit either the solution or the software. We use Vector Flow as the tool, and this is a tool which enables the client team to implement the to-be processes easily. It adds a layer that resonates the system's common objective throughout the operations environment, from order booking to RM procurement to dispatch of the goods.
Different companies have different challenges in scheduling as per their market challenges and plant conditions. An approach of curating a business solution first before customizing a software is interesting. Can you elaborate this with an example?
Let me explain with an example. Recently, we worked with a client from the glass making industry. Now, scheduling glass plants is one of the most complex operational challenges. First of all, there is a sequence of thickness campaign that we have to follow. This is for the annealing operation. And then post annealing, it is important to get the best output with minimum yield losses. But it is also important that these decisions on the thickness campaign do not lead to emerging bottlenecks in the downstream sizing operations. This dual need to do a good optimization across multiple work centers forces the plants to collect customer orders many days in advance, sometimes 45 to 50 days in advance. Now this in turn leads to many forecasted orders instead of real orders in the system. However, the customers revise their orders nearer to the horizon because initially they have forecasted and now they want to change to their real requirements.
Changing customer orders requirements can be a big problem for many plants. What problems did the plant face because of these dynamic requirements?
These conflicting objectives lead to multitude of problems in the plant. First of all, the customers experience a very poor reliability. The lead times is highly variable because sometimes you get it within 5 days and sometimes it can take as long as 45 to 50 days, despite giving the orders in advance. The downstream resources frequently become a bottleneck because we are planning the plant as per the thickness campaign. The yield and trim losses, this is from the annealing section, they increase because of the inability to optimize the sizing work centers. And then all of this will lead to frequent expediting in the plant, and then diversions of order, because by the time we have prepared the order, the customer is either not ready to take it, or they're saying that you need to delay it to a future date.
So what was the business solution developed for this client?
Our dedicated software development team, Vector Digital Lab, has designed a 3-horizon system for planning and execution in this glass manufacturing industry. Instead of using all forecasted orders to block resources, it used a planning model that actively scheduled orders based on a 15-day horizon in which customers actually wanted the delivery. In the short term of execution, it used daily, dynamic, multi-constraint, pull-based scheduling to release orders as per the active constraint in the system. It kept all the other orders, the forecasted orders actually, in the waiting bucket before scheduling in the planning horizon.
How did you manage to overcome the limitations in the way ERP was implemented to deploy the new solution?
There was an ERP at the client's end, but the configuration did not allow them to track orders and their completion through different stages of production. So what Vector Digital Lab had to do is they had to put a system to allocate available stock at different work centers to active orders dynamically, and thus predict their completion status, which was 99% accurate.
What were the benefits of the entire system?
First of all, order booking with confirmed delivery dates quoted from the system solved the sales side problem. With improved visibility of confirmed orders, the planning team could achieve much better optimization, both in the upstream and downstream operations. The execution team was relieved of living in this constant dilemma of whether an order was complete or not. Now they knew exactly how much more is to be produced to complete one order. Overall, the system was delivering with much lower overall stress.